Hello and welcome. Today we'll be learning how to calculate true wind using the dot method. Calculating true wind is one of the first functions we learn how to complete on maneuvering boards. Traditionally, the what method is taught. Today, I'll be teaching you the dot method. Why? Because it is better than what. Recalling what you learned when using the what method, you have to draw 3 different lines, plotting multiple different points, then draw backward from the triangle to figure out your true wind. With the dot method, you only have to plot 2 points to solve for true wind. The objectives for today's lesson are: given the ship's heading and an anemometer, convert relative wind to apparent wind. Using the dot method and maneuvering board, compute the true wind direction speed within 5 degrees and 2 knots. Step 1 of the dot method is to gather all the required information. The first thing that we want to get is the ship's heading and speed. The easiest place to find this is on your ECDIS display. On this example ECDIS, in the top right hand corner, you'll see that the ship's heading is 300 degrees true with a speed of 10 knots. The second piece of information we need is the relative wind. You get that relative wind from an anemometer. Reading an analog anemometer can be a little tricky because the needles aren't steady. They are constantly moving around. In order to get an accurate reading, take an average of what you see. In this example, the wind direction is 330 degrees relative and the wind speed is 15 knots. Step 2 is calculating apparent wind, which is converting relative wind into true degrees. We convert it through the simple equation. Apparent wind equals relative wind plus the ship's heading. Utilizing the information from our examples, relative wind of 330 degrees relative plus the ship's heading of 300 degrees true equals 630 degrees true. But wait, we can't plot this because it is greater than 360 degrees. We subtract 360 degrees from our answer, which calculates an apparent wind of 270 degrees true. In step 3, we plot our own course and speed. First, we'll write down all the information that we have, our ship and apparent wind information. We'll use them to figure out the appropriate scale. In this case, a 2 to 1. We circle it at the top. Now we'll plot our ship's information with a single point. Using our dividers and the 2 to 1 scale, measure 10 knots. We'll transfer that to the 300 degrees true line and make a dot where they intersect. In step 4, we do the same thing, just using the apparent wind information. Measure 15 knots with your divider and transfer that to the 270 degree true line, placing a dot at the intersection. In step 5, we're solving for true wind speed and direction. Using our dividers, we measure the distance between the 2 dots. Transfer the 2 to 1 scale to determine the true wind speed, in this case 8 knots. Next, we use our wings to find the direction. Line our 2 dots up and scroll the wings to the center of the maneuvering board. Where it intersects on the outer ring closest to the apparent wind dot gives our true direction. In this example, 230 degrees true. We just solved for true wind. Please pause the video now to complete the 2 practice problems. Press play to check your answers.